Hello, class and students of all ages and sizes. My name is Mr. Bouchard, and today we're going to do a measuring video and showing you some of the fine tools that scientists use. First, I will say I'm lovely apron shown here, which protects my clothes and body against spills and specimens if you're dissecting, or liquids if you're doing that. Then notice I have these beautiful goggles. These ones are the ones mostly you probably are familiar with. They're protected around the sides, the top, the bottom, don't look at my nose hairs, and it prevents fluids from getting in. You may see other types. There's types that look like sunglasses, sort of, and they come around the sides, but you guys are probably most familiar with these, and these are the most protective type. So what I'm gonna do today is talk about some things. First off, we got our nifty ruler. And when we talk about measurements, people, we are going to use the metric system. All right, we're not using the standard stuff. We're going with the metrics. Centimeters, millimeters, liters. We're going with grams, all of those things. So first we're gonna use is a ruler. And the ruler, we're gonna look at it, and on the bottom there it says centimeters and millimeters. And notice, for 1 centimeter, it is 10 millimeters. That's right. 10, sorry. I couldn't see from where I was.
Those millimeters look really tiny.
So this 1 centimeter is split up into 10 little parts, which make the millimeters. And when we look and measure things, we have to be sure what we're measuring, so we make sure we present it in the correct one. So what I'm gonna do is, I'm gonna flip this book over to you, our lovely old science book. Probably will never see this again. I don't know how long these are gonna be around for. Notice, I find out where the 0 is, and I'm gonna start right there on the edge, and I'm gonna go over all the way here. I'm trying to make it as straight as possible. And it looks like about 22, or 22.2, I can't see, 2.1?
22.2.
22.2 centimeters. Or you could say...
1. Yeah, I think it's 22.1 centimeters. Or could you also measure this in millimeters using the same exact ruler without moving it? What do you think?
You can. You go down to here. Now, this first 2 means 200. Then you go to the 22.1, so it'll be 221 millimeters.
Millimeters. Right.
And if you hear this wonderful voice, that is Miss Murdoch.
Hi.
Who's always helping me out, because sometimes I'm big goof and I mess up when I'm reading upside down.
So the first thing to remember is Mr. Bouchard showed this really beautifully. Make sure you're starting at the 0. Right? And the 0 is sometimes not the end of the wooden ruler. Sometimes the 0 is the line there, and you want to make sure that lines up with the edge of the object you're measuring, and that does. So then if you go over here, you find that on the top the gradations are in centimeters, and on the bottom the gradations, the same ones, are in millimeters. So if I move that very carefully, then did that move? It must have gotten thinner there. Okay, so that looks like 22 centimeters on the top. And then down here, 220 millimeters, right? So there's 22 centimeters if they were asking for centimeters, but 220 millimeters if they were asking for millimeters. Okay, Mr. Bouchard.
All right. Next, we're going to do mass. And how do you do mass? You do mass with our very lovely electronic scale. I'm moving this stuff out of the way, guys.
Fine.
It's a crazy time. What you always want to do is make sure, first off, we're measuring in grams. Sometimes you have to go through and figure out. Then, once I figured out what unit I'm using, I then want to clear out the scale so that makes sure it's read 0, 0, 0, because now we know there's nothing on it. And we're going to measure 3 things. A penny, a lovely seahorse, and I don't like these, but a tarantula.
It's okay. It's dead. It's not going to hurt you.
We will start with the penny first. So notice the 0, 0 again, I cleared it out. 0, 0, put the penny on. And all right, we gave it a second. I don't want to breathe over top, maybe breathe too much. 2.47 grams is what this weighs. So that's why I take this off now. And what I like to do is still 0 it out again. There we go. See, so that way we know it's a true measurement. Next, I'm going to go with our lovely seahorse. I'm going to call him Steve. Now, there is a little weight from the acrylic that it's in or whatever. I don't know what that weighs, so I can't really go back and forth. But we're going to include this in its weight. and it is 82.68 grams. All right. I'm going to then clear it out. I always like to clear, guys. I'm a very stickler about that because I make sure it doesn't. Here's our third one, our lovely little fuzzy wuzzy of a thing. And this one, 227.53 grams. Notice I included the 0.53. When we're talking about this measurement, we're going 2 decimal places over. All right, that's how far I want you to go. Don't just round up and be like, oh, 27, 228.
It depends on what they ask you for, but if the scale goes to 2 places, go ahead and write your data down to 2 places.
Excellent. Now, next we're going to talk about temperature. So Miss Murdoch is going to go and pick me up. Oh, first off, we do have our thermometers here, which these are going to be measured. Do we have the centigrade or in there?
Yeah.
Okay, these are centigrade. Good. And right here on the left, right here, or your left.
It's our right.
Yeah, you're right. Right there, you'll see it in centigrade. So what we're going to do is we've been boiling a cup of water.
You might notice that right now the room temperature of the room is, and if you look very carefully, I can see the room temperature is 24 degrees Celsius. Now I do not say 22. You may think, oh, but it says 20 and there's 2 tick marks there. You need to be very careful about the tick marks between the 20 and the 30 because what's going on is each tick mark is worth 2 degrees, not just 1, because there's 22, 24, 26, 28, and 30. That's going to happen a lot in lots of the things that you measure, so be careful of that. So this is actually 24 degrees Celsius. That's the room temperature of this room, which translates into, I don't know, around 70 degrees Fahrenheit. I'm not sure what. Okay, now I'm going to go over here and grab this beaker of boiling water, and I have some rubber gloves to use to make sure that I do not burn myself. And I'm going to bring it very carefully over to Mr. Bouchard and put it in front of him.
And remember, this said 24. We're going to let it stay in there. Should I put it all
Yep,
the way
go
down?
right in.
Drop it in?
It's still in for it.
And we're going to let it measure.
See, that red mark should come up.
Is it coming up?
It is, I can see it, I think.
I asked Miss Murdoch to see because she's back on the other side so we can maintain a little distance and not have to.
All right, yes, I can see that it is, yeah, it's going way up. Now, the actual boiling point of water in Celsius is supposed to be 100, so it should be close to 100, and it looks like it is. It's cooled down a little bit because I brought it through the air. It looks like it's about 98 or 99 degrees is where I can see the red mark. It's no longer near the 24, it's gone way up. The red inside the thermometer has gone up to, now it's at 98. And we have an announcement coming. Okay. Okay. Thank you, Saul. All right, so 98, and then still falling as I'm looking at it because it's sitting here cooling. But there you go, that's how to use that.
And now what I'm going to do is go get us, we have another beaker of water. We have had it in the freezer. Now, it's not frozen, but as you notice, as I took it out, you can already see it's starting to get like that condensation on it.
Yep.
So I want to get this in as soon as possible because...
Now this one I'm going to have to go in and really look because now the red should go down as you might predict. And I may need to take it out so that I can show you how far it goes down. Just give it a minute and then, yeah, it's still, I think it's still lowering a bit. Give it a chance to acclimate. Yeah, be careful, don't burn yourself. Okay, I think, yeah, go ahead and bring it up and you hold it and I'll measure it really quickly when it comes out. Okay, there we go. So now if you're using your tick marks correctly, it looks like above the 0, it's 2, 4, 6, I think it's about 8 or 9 degrees. And it's going up because now it's in the room temperature. So I think it was right at 8 degrees Celsius.
Excellent.
Right.
Now, those are our thermometers. Make sure we are doing it metric. So those we did. Go through my lovely list here. All right, so next I want to measure volume. And I looked at these and I go, mLs. Great, milliliters.
And what are these things?
They are lovely graduated cylinders. We call them graduated cylinders because I went to college and got a diploma. But notice, there's different sizes for different volumes of water. And as I get smaller, I get more accurate with my water. So in this small one here, now I look at it and I gotta check it at the meniscus, got some old knees. Sorry, it looks like 2 dashes below. So that looks at, let me see, 1, 2, 3, 18 milliliters.
Turn it around so we can see it.
Oh,
That's
I'm
all right.
sorry.
No, that's fine. I want to see if
I believe it's about 18 milliliters.
Yes, I think I would agree with that. Let me, oop, there we go. I'm just gonna hold it up so that students can really see that. Okay, so again, with the tick marks, you have to be very careful. You can see that where the blue water is, and actually, could you take a white piece of paper and put it behind this so they can really see that where there we go. Now, okay. So with a glass graduated cylinder, there's going to be more of a meniscus, but this one is actually nice and straight. So we've got the 15 watermark, and then it goes up to the 20 watermark, which you can probably see better if I do that, and now you can see it better. Okay, yeah, that's fine. Okay, so then actually without the paper, I think they can see it better. I just was wondering how that would work. So it goes 15, and then 16, 17, 18, 19, and 20. So let me just get the tweezers again so I can point for you. Okay, so we've got 15 there, and then 16, 17, 18, 19. I think it's right exactly on the 19 mark.
It was the 19?
Yeah.
Sorry.
Because that's how the count works. The larger tick marks are worth 1 each, and it's right on the 19. So that's 19 milliliters of water that I put some blue dye into. Okay, let's do the next one.
So I got a chair, guys, because my knees hurt.
Yeah.
Okay, so I'm just taking this like this for a second. I have to take this off, and this is bad just because my things are clogging up. So I want to show you again. Here's another one, and I believe, is it going by ones again, Miss Murdoch?
Okay, so 60 to 70, right?
Yep.
So now we have, let me put that over. I can't quite, there we go. Okay, 60, 1, 2, 3, 4, 5, 6. Yeah, each tick mark is worth 1. Yes.
Excellent.
So if that is true, and I'm really holding this up so you guys can see it. Oof. So it's right at the 65, 66. That's 66 milliliters, if you'll agree with me on that. Yes?
Yes.
What do you think, Mr. Bouchard?
Let me
Are
see,
you
let
going
me
to
see.
give me a confirmation there?
I confirm.
Yes.
66. Excellent job.
Okay.
Now, notice this next one we're going to get to is this big guy.
Big guy.
Oh, he's a honker.
Yes.
Now, if you look at the sides here, it goes up to 500. Ooh, ooh, ooh. The other one only went up to 100. This one went to 500. So each one of these little slashes, if you notice, it went from 350 to 400.
Right, so we've got, wait, here we go. There's 300, there's 350, and there's 400 up there. So each tick mark here is going to be worth more than 1. So 300 to 350, that must mean that this is 300, 310, 320, 330, 340, and 350, right?
Yep.
I hope that's clear, right? Those 310, 320, it's right below the 320. So I'm thinking 300, 310, 320, so it's like 319 is about the milliliters in there. So that's how you would do that.
And if you notice the difference, as we got bigger, you couldn't get as close of a point value because you had to sort of estimate because there was 10 notches between each of those counting.
That's right.
And that one, there was 1. Okay,
Okay.
on to our other stuff. So, I'm going to show you right here. We have what we lovely call, I've seen these for years, a microscope. Microscope, we have a specimen slide. This is where we'd probably do a specimen. You could see sometimes you do a lodia leaf.
Or some pond water.
Or some pond water.
Or anything like that that's too small to see with the naked eye. And once you have it on there,
You then have what we call a cover slip. And this cover slip, I'm sure you guys have seen how we talk about, oops, sorry, I got big, weird, bulky hands. So you sort of put it on one side like a door, and you just let it drop.
yep,
And by letting it drop, it sort of forces all the air out.
yes.
And what that does is then you're making a wet mount. Some of you might have done this in middle school in 6th, 7th, 8th grade. And then what you would do is you would slide it under,
Put it onto the stage.
put it on the stage, use the stage clips. Then we'd switch between our powers. We go low power first because you always go low. Then you'd use your objective knobs. Coarse objective first. This is an older one. We have newer ones that have the finer
We're not
things.
going to go into too much detail on that, but we'll get to microscopes later. But that's the microscope. That's the ones that we will use in the classroom, and hopefully we'll get to play with those later. Okay.
And what Miss Murdoch had been using the whole time? Forceps.
Yes, those
Tweezers.
are forceps. Yes. I've
I
been
get you like a
using
little
those to
crawl.
point at things, but you can also pick things up
All right.
that you don't want to put your hands on.
Next thing we show you is the reason we use test tubes. Because they have a lot of water in them. They have a lot of space to store liquid. So the first thing we have is our test tube rack.
And in this point, I think I'd like Mr. Bouchard to put on a pair of gloves.
Ooh!
Because that would be a good safety feature since you're going to be dealing with baking soda and some vinegar. And since these are chemicals, we will want to protect you while you're dealing with those. Even though they shouldn't be touching you, we are always about safety.
So I got the gloves on. Call me the good doctor. Now, notice I have gloves. I also have my protection of my eyes, and I have my lovely apron. So I am all ready to start handling liquids. All right, so Miss Murdoch, you're a very wise woman. Which one would you recommend I put in first?
I think it's good to put the liquid in first.
Okay.
So you have a small container of vinegar, it's all labeled, and an eyedropper. The eyedropper is good for putting drops in that you don't need to measure. So we're not measuring an exact amount of milliliters here, we're just dropping some vinegar into a test tube. A test tube is also a tool where you're not measuring something. You are just providing an area to see a sample more clearly, a small sample, or a chemical reaction, which this is going to be.
Is that enough, you think?
That's good. That's
Okay.
perfect.
All right.
All right, so put your vinegar down. And now we have a metal shovel that he's holding that is able to take small amounts of solid. And again, we're not measuring this. We're just taking a small amount of solid, very small. Okay, you're not going to need much. And if many of you may already know what's about to happen, so if we put that baking soda in with the vinegar, let's see what happens. Yeah.
Woo! Woo! Party!
Okay.
And notice, when you do this, you waft, you don't insert a nose over. I'm not going to because vinegar is very powerful. But when you're talking about smells and stuff, you go like this, you keep it away. And you can sort of hit on the bottom like I'm doing to cause the reaction.
That's a very good mixing technique to make sure that the reaction has completely gone to completion. Yes.
And as you can see
Hold the
now,
top firmly and kind of hit it, gently tap it with your finger on the bottom, and that mixes it so that you can be sure the chemical reaction is complete. That's a very good use of test tube technique.
thank you.
Very good.
And ladies and gentlemen, I believe, let me ask my little Miss Murdoch, have I forgotten anything today?
No, I think that is all. That is what we wanted to show you today, and hopefully that will help you when you're doing your work with measuring in biology class. Thank you.
Have a wonderful day, guys.